My name is Juan Tuban, and I will be going over question B from part 1 of exam 2, which is on equilibrium. So this question is asking us to find the value of Kc for the following reactions at exactly 95 degrees when they give us a Kp value, and it's also asking us to rank this from largest to smallest. The first thing that you should do is, what is the question asking? It's asking us to find the Kc value. Next, you need to find an equation that needs to be used. In this case, it's going to be Kp equals Kc times the gas constant times temperature in Kelvin raised to the coefficient values of the moles, products minus reactants. And third, you need to make all the conversions needed. They give us a temperature in Celsius, but it needs to be in Kelvin. So we need to convert that into Kelvin by adding 273 Kelvin, and that's going to give us 368 Kelvin, which is the temperature that we need. For the first reaction, we have chlorine gas plus water in liquid form yields to hydrochloric gas plus oxygen gas, and the Kp value is 0.0752. So first, you need to balance the equation, and second, you need to make sure that you don't account for the moles of liquids. You should only be counting the moles of gases and solutions, because liquids do not appear on the equilibrium constant. So we have 2 moles of gas on the reactant side, we have 5 moles of gas on the product side. So all we have to do is put everything into the formula. Kp equals Kc times the gas constant times temperature raised to the coefficient value of the moles. The gas constant is 0.08206 liters times atmospheres over moles times Kelvin. And the temperature that we found earlier is 368 Kelvin. So we're going to put everything together. 0.0752, which is the Kp value, equals Kc, which is the value that we're trying to find, times the gas constant times the temperature. And this is going to be raised to the coefficient values of the moles, which is going to be products minus reactants, and that's going to give us 3 moles. After we multiply these two values together and cube it, we're going to get this number, and we're going to divide by it to isolate Kc. And after we do that, we're going to see that Kc for the reaction, for the first reaction, is 2.73 times 10 to the negative 6. Make sure with your sig figs, they give us a Kp value that has 3 sig figs, so we also need 3 sig figs for the Kc value. The second reaction is nitrogen gas plus hydrogen gas yields to ammonia gas, and the Kp value is 4.3 times 10 to the negative 3. So we're going to have to balance the equation again, and we're going to see that there's going to be 4 moles of gas on the reactant side and 2 moles of gas on the product side. So again, we're going to put everything into the formula. The Kp value, 4.3 times 10 to the negative 3, equals the Kc, which is the value that we're trying to find, times the gas constant times the temperature raised to the difference between the products minus the reactants, which is going to be negative 2 moles. After we multiply these two values together and raise it to negative 2 and divide by it to isolate Kc, we're going to find that the Kc for the second reaction is 3.9. For the third reaction, we have nitric oxide gas plus oxygen gas yields to nitrogen dioxide gas, and the Kp value is 5.0 times 10 to the 2. After we balance the equation, we're going to see that there's going to be 3 moles of gas on the reactant side and 2 moles of gas on the product side. We're going to put everything into the formula again, which is going to be Kp equals Kc times the gas constant times the temperature raised to the change in moles, which is 5.0 times 10 to the 2 equals Kc, what we're trying to find, times the gas constant times the temperature that we found earlier, raised to 2 moles of gas, which is the products, minus the reactants, which is 3 moles, and that's going to give us negative 1. After we multiply these two values together, and we raise it to the negative 1 and divide by it to isolate Kc, we're going to find the Kc for the third reaction is 1.5 times 10 to the 4th. Finally, we just have to make sure that we rank it from largest to smallest. So we're going to find that Kc for the third reaction is greater than the Kc value for the second, which is greater than the Kc value for the first reaction. numerically, it would also look like this. 1.5 times 10 to the fourth is greater than 3.9, which is greater than 2.73 times 10 to the negative 6. As an overall note, just make sure that when you are trying to solve this kind of questions, you are balancing the equation, you are identifying what you need to solve for. So in this case, we needed to find Kc. Also make sure that you only account for the moles of gases and solutions and not liquids. And finally, make sure that your sig figs match with the Kp value that you were given. This has 2 sig figs, so the answer should also have 2 sig figs. And for the ranking, also make sure that you identify if it's from smaller to largest or from largest to smallest.